We would like to welcome everyone this morning to our third Harwell Net Zero Energy Conference. I'm Emma Southwell-Sander, the Harwell EnergyTec Cluster Development Manager. It looks as if we've resolved any last-minute issues regarding the login this morning, so apologies for that. You will see from our agenda that we have some incredible speakers today representing industry, academia and government, all focused on the future of clean energy, who will be addressing our overarching topic, how to expedite net zero technology in the UK. I am here if you have any questions that you would like to input into the chat facility throughout the day. As you can see from the agenda, we have divided the day into two sections, starting with our key speakers. Professor Paul Monks, the Chief Scientific Advisor at BEIS. Dr. Barbara Ganelli, Director of Clusters and Campus Business Development at UKRI STFC. Martin Aston, Forvander, previously Airbus. Dr. James Barth, Head of Aerothermal Engineering at Reaction Engines. And Eric Brown, the CTO of the Energy Systems Catapult. Please take the time to enter the platform networking area in the coffee break and take a look at the resource page, which features some of the latest research and technologies coming out of the Harwell EnergyTec Cluster. There will also be coffee tables which provide the opportunity to network with other delegates. And following the coffee break, we will move into our panel discussion. I will now hand over to Professor Paul Monks, who's the Chief Scientific Advisor at BEIS.
Good morning, everybody. I'm sorry I can't be with you today. Minister Kwarteng sends his apologies, but obviously since he's become Secretary of State for the department, he can't be with you today, and he's asked me to give you this message on behalf of the department. I'm glad to know that today important people like you are coming together to tackle the challenge of climate change. I myself have visited Harwell Campus a number of times, and I have been impressed to see the range of research on display there, from space science and astronomy to particle physics, nanotechnology, and even the creation of new materials. It's the kind of pioneering work that is so often undertaken just out of the spotlight in this country, and yet innovation like this is critical to our future. Because when it comes to fulfilling our net zero commitment, we need bold new approaches and products. And seeing this research in action has demonstrated that we have what it takes to step confidently into the future and double down on green recovery. This will mean large-scale changes to our energy systems and substantial new low-carbon infrastructure, alongside shifts in how we travel and how we buy and how we may use energy. The question is, how do we achieve this? And the answer? I believe it is absolutely clear in our intentions to invest in these innovations in net zero and to get started now. This was the Prime Minister's goal when he announced his ambitious 10-point plan in innovation and the Green Industrial Revolution just before Christmas. The 10-point plan spanned clean energy, buildings, transport, nature, and innovative technologies. It will mobilise 12 billion of government investment to create and support up to 250,000 highly skilled British jobs and unlock 3 times as much private investment by 2030. Through our world-class innovators, entrepreneurs and financial institutions, we are focusing progress on the key technologies of the future. Products that can help us at home, which we can sell to a decarbonising world. The transition to a zero-carbon economy creates new opportunities, industries and jobs, something that is especially important when this pandemic has dealt such a ferocious blow to the global economy. So our vision for the UK as a global leader in decarbonising technologies has not changed. And I support this. I'm pleased to confirm on behalf of the Minister that the Department will be launching soon a new £1 billion Net Zero Innovation Fund, the aim of which will be to accelerate the commercialisation and innovation around low-carbon technologies, systems and business models in power, buildings and industrial sectors. The new funding aims to decrease the costs of decarbonisation and is part of a wider commitment to raising the total R&D investment to 2.4% of GDP by 2027 and includes recent announcements to invest 100 million in the brand new greenhouse gas removal technologies such as direct air capture. Alongside this, we recently published the Energy White Paper, which establishes how we aim to integrate these innovations into our everyday lives, transition away from unabated fossil fuels to clean energy by 2050. And we will follow that with a comprehensive net zero strategy later this year, which will set out the government's vision for transition to a net zero economy. The next phase of green innovation, I hope, will bring down the cost of net zero, transition and nurture the development of better products and new business models. Green investment and you, the people at Harwell today, are the heart of that. And our innovation investment provides a strong signal to the market that the government is committed to strengthening technology innovation in support of its clean growth objectives. We, as many of you will well know, were the world's first major economy to legislate for a net zero target, committing to become net zero for greenhouse gases by 2050. And ahead of COP26, we are bringing forward ambitious new plans to reduce emissions across key sectors of the economy. So that as the world recovers from coronavirus, we can be example not just of how to rebuild, but how to build back better and build back greener. With UK firms and innovators firmly in the spotlight and benefiting from our committed approach to reaching net zero. I do hope you have a wonderful day as part of the Harwell Net Zero Conference, and I thank you for your time. Thank you.
Thank you, Paul, for leaving us with a greater understanding on the future of clean energy in the UK. I will now hand over to Dr. Barbara Ganelli, who will say a few words on the strategy behind the EnergyTec Cluster at Harwell.
Thanks, Emma, and good morning, ladies and gentlemen. I'm so pleased to be with you today at our third annual EnergyTec conference, even if it's only virtually. I'd like to add my warmest welcome to all of you and a big thank you to all the speakers and the panelists. We want our EnergyTec cluster to be at the forefront of the clean energy agenda, providing support to companies and government to accelerate the drive for a sustainable energy future and make this a strong engine for economic recovery after these unprecedented times. The push towards net zero carbon energy is a high priority for the UK government. The Climate Change Committee's recommended pathway to net zero brings forward the UK's previous 80% target by nearly 15 years. This is an exciting challenge that will stimulate innovation and create thousands of new jobs. Also, the government's recently published 10-point plan for a green industrial revolution highlights both the scale of the challenge and the ambition to meet it. The EnergyTec Cluster at Harwell is intended to support government in this endeavour. We are already starting to work alongside policy makers, accelerating and integrating multiple efforts from across the UK to address a whole range of net zero applications that collectively will shift the dial towards this target. This year's EnergyTec conference will highlight the key developments and innovations being used to reach a greener future. And specifically, I would like to highlight our development of a net zero living laboratory at Harwell, which is at the heart of both the Living Oxford initiative and the Oxford-Cambridge ARC strategy. The development of this living laboratory is also embedded in the UKRI Environmental Sustainability Strategy, which sets out an ambition for the organisation to be a leader in environmental sustainability, with a target for its own operations to be net zero by 2040. UKRI operates research laboratories, centres and facilities, and this strategy applies to all UKRI investments and operations, including those on the Harwell Campus. The idea of the living laboratory recognises that the Harwell site, with its multiple users and variety of facilities, is an excellent analogue of many mixed-use industrial sites up and down the country. As such, it is a good place to develop, test, evaluate and refine novel energy systems in a real-world environment before they are rolled out more widely. But there is also another very important aspect, which will help attract long-term commercial commitment to the Living Laboratory initiative. As well as technical solutions, companies will be able to develop and evaluate the right business models and test their commercial viability in a broader system context. This can accelerate the development of new solutions, and of course they can do this with the added advantage of ready access to the wide variety of technical knowledge that is embedded in the Harwell Campus and its wider networks. The Harwell Campus itself is developing rapidly. It is operated by a public-private joint venture partnership that includes UKRI STSC, alongside the UK Atomic Energy Authority and Brookfield. Because of its makeup, the JV has a vested interest in trialling and adopting new sustainable solutions. Added to this, as custodian of a major UKRI national laboratory, STSC can use its convening power to bring together the full value chain of stakeholders, from customers and end users to regulators, community leaders and government, to ensure that products developed are fit for purpose and ready for market rollout. The Net Zero Living Laboratory model is one that we intend to develop and showcase on an ongoing basis at Harwell, but working with others throughout the UK and with a very strong link to our sister campus at Daresbury in the northwest of England. The forward plan for the Living Laboratory encompasses, but will not be limited to, a number of complementary strands, which I will briefly discuss now. To start with, we will utilise UKRI STSC campuses, expertise and equipment to test, validate and showcase cutting-edge net zero technologies, including battery research, storage, electronics, photovoltaic systems and electric vehicle charging. We will also deploy integrated energy systems across the campus itself through UKRI STSC estates and facilities and the Harwell joint venture, with the STSC's Daresbury campus supporting the development of data products for smart energy systems to manage energy usage, align supply to demand, divert renewable energy to meet peak demand, and provide access to energy storage when supply exceeds demand. As well as this, we want to establish a cross-UKRI Living Laboratory initiative for projects encompassing energy, environment and transportation, involving other organisations such as DEFRA and Natural England. And we intend to expand the existing cross-cluster proof-of-concept programme to include a demonstration element. Examples would include the green ammonia demonstrator and the battery research laboratory. The existing programme has been running successfully for the past 4 years within the Harwell and Daresbury high-tech clusters, and to date has funded 56 projects. The expanded programme will de-risk innovation and forge new collaborations between industry and the facilities on the campus and beyond. exploiting the shared infrastructure provided by the plug-and-play platforms that will be developed by EnergyTec stakeholders. All of this will drive net zero innovation that can be deployed across the UK with supporting governance, policy and regulations. So what progress have we made since last year's EnergyTec conference? An advisory board has been established, including government representatives, industry thought leaders, including large and small organizations, social science experts and disruptive tech. This board will provide essential guidance on future developments. The Harwell Campus joint venture is already incorporating a sustainability program across the campus as a testbed for net zero technologies for new buildings and existing facilities, which include battery energy storage, monitoring of energy usage, photovoltaic systems, and electric vehicle charging. STSC estates are supporting the UKRI environmental sustainability strategy with a new solar panel investment initiative on the roofs of RAL buildings and other areas on campus. This will incorporate further battery energy storage and monitoring underpinned by the Data Integration Platform initiative at our sister campus at Dasbury. The Faraday Institution, based on the campus, is the knowledge partner to STEPS, a Europe-wide project aiming to democratise the energy storage industry. Together with the Harwell EnergyTec Cluster and Cambridge Cleantech, they will offer SMEs a user-centric, demand-driven approach to bring their products closer to the market through tailored testing, with the Harwell Campus used as a testbed. We are also supporting the development of other initiatives like the Darwin project, which is enabling the testing of connected and autonomous vehicles on the campus using 5G and satellite technology together. This is part of a 4-year trial program supported by the European Space Agency and O2. There are also new game-changing developments by innovative SMEs such as QDOT, who will be in our panel discussion later on, and who are developing technology to cut electric vehicle charging time by 2/3. And our green ammonia initiatives to develop a technology which could offer further options in the transition to net zero carbon dioxide emissions, including its use as a zero carbon fuel or as an hydrogen carrier, or to provide a solution to energy storage from renewable such as offshore wind. So what are our next steps? We are certainly making good progress. But the Net Zero Living Laboratory is a huge initiative with huge potential, and we now need a step change in the rate of development to meet the challenging net zero targets. If you haven't already, we would urge you to join us and figure out how we can best work together to meet this enormous undertaking. It goes without saying that developing green energy solutions is something that we should do for the benefit of the entire planet. But it's also an incredible opportunity to grow our economy. If we can develop world-leading solutions to these pressing issues, we can create jobs and prosperity. But we won't succeed in this if we approach it in a half-hearted manner. We have the knowledge, we have the imagination, we have the expertise. Let's combine this with drive and ambition and work together to make this happen. Thank you, and I hope you enjoy the rest of our event today.
Thank you, Barbara. I will now hand over to Martin Aston, who's currently with Forvander and has previously spent 40 years with Airbus. Martin is going to take a look at our overarching theme of how to expedite net zero technologies in the UK with engineering.
Hello, my name is Martin Aston. For the last 15 years or so, I've been leading a large number of ambitious research projects aimed at improving the engineering process through the adoption of digital technologies. Today, I'm going to talk about how important that improvement to the engineering process is in achieving net zero, but also give you an insight into the Brunel Challenge, which will help us actually achieve that ambition. So as I was saying, achieving net zero is extremely complex. Even though a product itself may not emit any zero emissions locally, for example, an electric car, when we consider the entire ecosystem that goes with that product in terms of its operation, its manufacture, its distribution, we find it's a very different situation. So we need to understand the performance of that ecosystem as a whole. There's a lot of talk about system of systems, and that system of systems has many complex interactions, many interdependencies that have involved very dissimilar products, different companies, different organizations, and even different cultures. So each one of those interface points will need to interact as efficiently and effectively as possible. So in that system of systems, we're finding cases where technological, commercial, and regulatory integration is essential. I'll come back to this later and show you a worked example of this and why it is so complex and why achieving net zero is such a challenge. And many industrial sectors are going to have to find themselves in a situation where they're moving from evolution of existing products to revolution if we're to achieve these very ambitious targets. That makes the challenge even more difficult. So something that's already complex is made even more complex by the need to actually deliver radically different products very quickly. And actually predicting the performance of those products, how are they going to deliver the necessary environmental impact improvement? How do we actually prove they do that, validate them, and demonstrate them within that entire ecosystem is going to be extremely complex. But the only way we're going to deliver net zero is if we can actually achieve that. So a transformational change in engineering is absolutely essential if we're to achieve that ambition. It's worth just spending a couple of minutes explaining what engineering is, because I think engineering is a very misunderstood word. It's a misunderstood discipline. Many people think that an engineer is someone who comes and mends your boiler, but that couldn't be further from the truth. At its core, engineering is the conversion of knowledge to useful things. So as we see here, engineers take a knowledge of science, they apply both creativity and mathematical processes, and using that, they deliver transformative products, but also transformative services. So at its core, it's a very intellectual, but also a creative discipline. When we go back to the ambitions of net zero, science has set the agenda that we need to address, but science in itself cannot deliver the solution. It's engineering and engineers that will actually deliver the products, deliver the services that actually address the climate change problem. So I said earlier that we'd show a worked example of this so-called system of systems and how difficult it will be to achieve net zero. So the example I've shown here is of a hydrogen-powered aircraft. So a hydrogen-powered aircraft at source, at its point of use, will be zero carbon emission. But that's only a very small part of the overall equation. So starting on the left, if we're to generate the hydrogen, we need to generate a lot of power. The actual process of producing hydrogen is very energy intensive. And so we need to look at new ways, new clean ways of generating the power to actually deliver that hydrogen. Then there's the hydrogen production process itself. That will absorb energy. We have to distribute it to the point where it's needed. So not many airports at the moment have hydrogen supplies. And so there's something there that needs to be addressed. We need to also distribute the power that goes with it as well. And then there's the airport, there's the ground operations, there's the surface transport getting to the airport. If we have a zero emission aircraft but continue to use diesel buses, or diesel cars to get to and from the airport, then we're not going to achieve that net zero ambition. And then on the right-hand side, we need to consider the actual raw materials that go to actually produce that product, the actual distribution of those, because they come from all over the world. We need to consider the production process. We need to consider how we actually distribute those components and then assemble them into the vehicle itself. And then finally, when we get to the end of the life of that product, we need to consider how we actually dispose of it. So as you can see, this achieving net zero is far from developing just the zero emission product. It's actually understanding how that product fits within an entire production, operation, and disposal ecosystem. And that's going to require a very, very different approach to engineering to what we have today. So how are we going to deliver the answer to this challenge? Well, currently we're working on establishing a very ambitious program known as Brunel Challenge. It's a national program of engineering transformation. It's involving all key industrial sectors. As you saw in the example before, what starts off as an aerospace challenge is very quickly a power generation, a surface transport, as well as an aerospace problem. What we aim to do with Brunel Challenge is to provide industry with the people and the processes to accelerate the development of that generation of products needed to achieve net zero. It's important to note there that a key part of this is people. People are where the innovation happens. People are where the good ideas come from. And we need to understand how to best use people within that transformational process. But we're going to embrace digitalization to make that a reality. This isn't just a case of digitizing today's process. It's looking at transformational change through digitalization. Consider the transformation of going from a landline phone to social media, and you get an understanding of the level of transformation we need to see in engineering. And we're going to make full use of existing and emerging research ecosystems to support that delivery. So if we look at the Harwell EnergyTec Cluster, that is an ideal way to actually engage both industrial and government organizations. And the living laboratory will give us an opportunity to actually test, validate, and actually showcase both innovative technologies, but also innovative processes as well. So to summarize, re-engineering engineering is essential if we're to deliver to the net zero ambition. As you've seen, the system of systems needed to achieve that will require far greater integration as well as technological innovation. An evolution of today's engineering processes will not suffice. Only transformational change will deliver what we need to achieve. Thank you very much for listening and enjoy the rest of the event.
Thank you, Martin. That gives us a real insight into how we can tackle fast-tracking net zero technologies through the TRL levels from R&D to commercialization. I will now introduce Dr. James Barth from Reaction Engines.
I'm really pleased to be able to present this project about ammonia fuel for aviation. That was the joint project between Reaction Engines and the STFC. Today I'm going to tell you a bit about Reaction Engines in case you don't know much about us, go through the motivation for the project itself, how it was set up, what we learned doing it, and what could come of it in the future. So Reaction Engines, as a company, is about 200 people. We're based in the Cullum Science Park, just down the road from Harwell. And the core of our focus is on this engine called Sabre, the synthetic air-breathing rocket engine. And that engine is designed to be able to take off from the runway up to Mach 5 breathing air, and then transition to a pure rocket mode to reach space. And at the heart of this is some really advanced heat exchanger technology, which allows this sort of engine to be possible. Now that same heat exchanger technology could find spin out in a number of segments. One place we're looking at quite actively is high-speed flight, which is a really popular avenue for potential future applications. Another big avenue for it is anywhere where you need thermal management. So that could be in aviation, that could be in automotive, it could be in energy generation. The heat exchanger technology we've developed could offer a step change in performance in any number of applications. And that's actually really how this project came to be in the first place, really. Now, why do we want to look at aviation and zero carbon fuels? Well, because getting aviation to net zero is a huge challenge, and a challenge we have to meet. The UK is committed to net zero by 2050, and that includes aviation. These charts from Sustainable Aviation, published in March of 2020, show one potential path where you're looking at the effect of carbon price on demand, improved operations, fleet upgrades, sustainable fuels. But doing all those things, you still have to have some kind of market-based measures to get to a net zero solution, which is certainly a possible way of doing it, but it's a bit of really accounting sleight of hand to show that someone else is effectively not emitting on your behalf. If, on the other hand, you could find another route to decarbonizing aviation that didn't require that, you would have a very compelling thing on your hands. And that's what ammonia could possibly give you. Ammonia offers you a route to zero carbon air travel that is quite cheap. If you look at this chart on the right, it's from the International Energy Agency. These are the near-term and long-term, so 2030, 2050 timescale production costs for green hydrogen, ammonia, and synthetic aviation fuels. And you can see ammonia is actually very cost competitive. But it's cost competitive for more reasons than just its production costs. Ammonia has a pre-existing infrastructure, and as we'll show in a few slides' time, you don't actually necessarily need to change as much about your aircraft or your engines. And that means potentially you could also do these changes to a green or zero carbon aviation system in much less time than other systems might need. That's also aided by the fact that there's an existing ammonia infrastructure. 1 to 2 million tons of ammonia are loaded and unloaded off of deep sea going ocean vessels every month as they ship it around the world. That infrastructure is safe. Despite ammonia's toxicity, we've been handling it as a species for more than 100 years without major incidents. It's also a remarkably low fire risk, especially relative to something like jet fuel. And that's actually one of the main challenges of using ammonia in an aviation context, is it's not easy to burn. But if you can get it to burn, you're left with a fuel that has zero carbon, which means zero CO2 and zero soot emissions. There's no sulfur in it to create sulfur oxides. And, well, it is a nitrogen-bearing fuel. It is possible to burn ammonia without generating a lot of NOx emissions. And ammonia itself is used to scrub NOx emissions. So you have the potential, using ammonia, for a true zero-emission aircraft and engine combination. So this project was set up to investigate how that might look. And so the four main goals were to see how we could take reaction engines, thermal management technology, and STFC EnergyTec's catalyst technology to make a zero carbon aviation system. So within this was four main goals. One was looking at how that system would look thermodynamically and physically, both at an application and demonstrator scale. Apply reaction engines, heat exchanger technology to the vagaries of using ammonia as a working fluid to take heat out of a jet engine's exhaust. We explored how reactors could be set up to use the STFC's catalyst technology, and we also investigated how that catalyst itself performs at elevated pressures, which is something that hadn't been done before. And the results were very promising. The catalyst performance at pressures up to 5 bar, which is how high we could go during the scope of this study, were showing equal or better performance at elevated pressures, which is really intriguing behavior and something we're keen to explore more. Heat exchange and reactor designs were explored particularly for the demonstrator scale, and we showed that we could develop heat exchangers. Some of them are shown in picture form on the bottom right-hand side of this graph, and they show really good low pressure drops, which is what you need if you want to integrate them into the exhaust of a jet engine. Cycle-wise, we showed that existing turbofans can burn an ammonia-hydrogen blend with only minor changes to the engine architecture. So if you have a cracking reactor that can give you something like 30% of the ammonia cracked into hydrogen and nitrogen, you can use the exact same turbo machinery, which means all you need is a new combustor and new heat exchangers, which is much less than a brand new engine in terms of development cost and time. We also looked at the impact of using a cycle like this in an aircraft similar to an A320 and showed that it could fly in the neighborhood of 2,000 kilometers, a little bit more actually, which is enough to cover the vast majority of the short-haul aviation market today. It's also potentially feasible to integrate this sort of jet engine concept with burning ammonia with a ammonia-based fuel cell to come up with a hybrid electric propulsion system, which would give you much better range than even this would give you. And the way such a system like this could work is you would have ammonia, which when you chill it to about 200 Kelvin is actually very similar to kerosene in terms of its density, which means it can be stored in wing tanks. That ammonia could be taken from the wing tanks and pumped through heat exchangers in the exhaust of the jet engine, taking some of the heat that would otherwise be dumped overboard to heat the ammonia up to a temperature where when you put it in the presence of catalysts inside a reactor, it cracks readily into hydrogen and nitrogen. That hydrogen and nitrogen ammonia blend could then be burned inside the engine, and the main byproducts would be nitrogen and water vapor. So it's a really promising architecture for future aircraft systems. And that's really one of the big takeaways of this is actually something that could be done feasibly, and it could be done quite quickly. With the right funding and the right motivation, you could see aircraft fueled by ammonia flying by 2030. That's perfectly technically possible. And that's largely driven by the fact that you don't have to reinvent the aircraft or the engine in order to do this. But beyond aviation, the sorts of technology, the reactor and heat exchanger technology, would have wider application in a future zero carbon economy. So it could be used in any number of industries. And a great place to test a lot of these technologies could be something like the Net Zero Living Laboratory Harwell is trying to get set up. So with that, I'd like to thank you for your attention.
Thank you, James. We can really see some of the opportunities and challenges that reaction engines and actually our SMEs face in the UK and what is required to support companies with new cutting-edge technologies moving forward. I am now going to introduce Eric Brown, who is the CTO of the Energy Systems Catapult. Eric is going to cover a whole systems approach and talk a little about how we can link the Energy Systems Catapult Living Laboratory to a Harwell Net Zero Living Laboratory.
Good morning, everyone. I'm Eric Brown, CTO at the Energy Systems Catapult. Thank you for providing me the opportunity to join you today. I'm really pleased to be able to be part of today's EnergyTec conference and to be able to share some thoughts with you about the role that innovation will play in the complex task of achieving net zero. Now, some of you may not be familiar with the Energy Systems Catapult, so I thought I'd start by just making a few brief comments about the work that we do and the nature of the catapult itself. So the catapults are an innovation intervention by government that were established to support creation of sustained economic growth for the UK, and to do that by helping innovators commercialize their good ideas. There are 9 catapults across the economy, all share this goal of economic growth, but the Energy Systems Catapult, in addition, seeks to do that with net zero as a very clear objective, and hence we focus on clean growth. We do our work by collaborating with academia, with government, and with industry, and in all our work, we seek to take a whole systems approach across the whole energy value chain, across all energy sectors and vectors, and addressing not just technology, but also value propositions, business models, systems integration, policy, regulation, and so on. So we have a broad portfolio of projects and initiatives underway, and we're always open to conversations about our work. So please feel welcome to be in touch. Turning to the question for today, how to expedite net zero technology in the UK. This is a question which aligns very well with our mission and our work. If we look across the innovation landscape at a very high level, we recognize the need to do 2 things. First, we need to understand what technology or other interventions are needed to support our vision. And to do that, we can use familiar techniques like techno-economic modeling and so on to reveal what these insights are that we're going to need to move forward. And secondly, once we have this understanding, we can then build an innovation pipeline by encouraging and deploying resources and funding or applying other mechanisms to provide a sense of direction for that innovation pipeline. Now, this is necessary, but it's not sufficient, and it can lead to innovation, but it doesn't necessarily lead to successful application or uptake or scaling or indeed commercialization, and hence may disappoint us as we pursue net zero. So the question might be, how can we look at this differently? Are there other needed steps that we can explicitly draw out? Can we be more systematic in the approach that we follow? So here we start from the same place. We seek to establish our vision, and we do so using techniques such as techno-economic modeling, with which we're all familiar. And this will help us to understand what we could or should or must do to achieve net zero. We can then consider the market failure we're trying to address and how we can create pull for the innovation as opposed to trying to push it. And one perspective on this, to sort of illustrate what I mean by that, is to be clear about the role of the consumer and how they will engage or perhaps not engage with the implied change. Once we understand what market failure we may be trying to address, or as we seek to create a market that's actually going to be addressable, then we then seek to understand what barriers may exist or what enabling conditions need to be in place for the innovation to address that market failure successfully. And several are mentioned here. They span a broad spectrum of considerations, from digital infrastructure to people and skills, from test and demonstration through to policy and regulation. Understanding these enable us to build a pipeline that is much more focused on outcomes and to be clear where, when those innovations are placed in context, there's a likelihood that their path to acceptance and uptake will be much better understood and facilitated. With this, we can then understand how we want to respond. What build or buy decisions do we make with respect to that particular innovation, which is another way of saying what role does the UK want to play in terms of the creation and deployment of that particular innovation. Now, clearly, this is not as linear a process as might be suggested by the way I've drawn it. It depends on, it's iterative, it depends on us approaching this in a way that we understand all the complex interactions between the actors and components here. And we also need to understand how we get the flows of information to allow the best decisions to be made at the best possible time. So if we accept this as a structure for thinking about how we support and encourage innovators to develop and deploy their good ideas, what I'd like to do with the time I have remaining is to focus on one aspect of this, and that's specifically the role of test and demonstration in enabling innovation. It's one of the enabling conditions referred to here. Now, I know this is an area of interest and endeavor that we share with the team here at Harwell. So we believe that test and demonstration plays a key role, an essential role, in fact, in expediting the journey to net zero. And our work here is focused in our living lab. So what is our living lab? Well, it's an independent, digitally enabled facility that allows innovators to do four principal things. Firstly, they can test their innovation in a real-world operating environment. Secondly, they can move these innovations forward closer to commercialization by virtue of this facility providing commercial context for their work. Thirdly, it allows them to work with others to achieve desired outcomes. And fourthly, it supports the process of raising money or investment to support their innovation. And that does that by providing evidence that helps mitigate risks associated with that innovation. All of this is in aid of the overarching objectives of growing businesses and hence the economy. And second objective here, of course, is to help government and the regulators in their work to understand what conditions would be helpful to enable and encourage innovation to happen and to happen successfully. Now, I don't propose to describe the living lab in any detail, but I would like to just illustrate that it comprises real people, real consumers in real homes interacting with the energy system. And as I illustrate here, it comprises a whole spectrum of technologies, from heating and cooling through to EVs and storage, other types of technologies that would be deployed in the energy system of both today and increasingly in the future. And it also serves a wide variety of users, those who want to provide services to consumers, those who manufacture devices, government regulators, and indeed the networks who will deliver energy to the consumer themselves. So what does it do for innovators? Well, again, I'm not going to go into a great deal of detail here, but from an innovator perspective, it serves the objective of addressing the question how to understand and create market pull and how to access and respond to it in a really effective way. It also allows the single innovator to work with others to understand how their innovations might helpfully work together, or what are the implications of the interactions between systems and technologies that are being deployed. From the policy perspective, the Living Lab provides a place where it's possible to gain an understanding of the interventions that are going to be needed, and to do that in a safe space. So it gives the ability to explore potential risks and benefits, and importantly, to build an understanding of what it's going to mean for consumers, because ultimately they're the beneficiaries of what we're trying to achieve here together as we seek to achieve net zero. So taken together, we believe the Living Lab makes a really significant contribution to lowering the barriers to innovation and building that pipeline of innovation, not just the technologies, but also the business models, the policy, the regulation interventions that are going to be needed, to building that pipeline of innovation that's going to be needed to achieve net zero. My final and closing comments relate to how we can use the Living Lab with others. And the example I show here is work that we're currently discussing with the Power Network Demonstration Centre in Strathclyde. And here what we're doing is we're connecting the learning from the Living Lab directly to the measurement of network interventions and impacts. And so what we're able to do is better answer the questions such as, what are the real implications of EV take-up on networks? What are the real implications of deploying flexibility in the system? And the idea here is to combine the strengths of the two facilities to different aspects of the same problem to achieve much more powerful insights and outcomes leading to more effective action. I think there's great potential to explore similar thinking with the Living Lab work happening here at Harwell. I hope that we'll be able to do so. So with that, I'd like to say thank you once again for providing me the opportunity to be here today. I would welcome the opportunity to discuss any aspect of our work with you, and look forward to doing so sometime in the near future. Thank you.
Thank you, Eric. I think now we'll go into a few questions for our key speakers. So if you do have any questions, if anyone from the audience want to enter those into the platform, that would be fantastic. I have a few that have been fed through already. So starting with Barbara. Barbara, you said that the Harwell Net Zero Living Laboratory Initiative will require a step change in the rate of developments. How are you going to achieve this, and what support do you need from government to provide this momentum?
Very good question. The Living Lab initiative requires the support of a broad range of stakeholders, including government. Specifically, we are looking into government to provide focused investment that will kickstart co-investment from industry and create the sort of partnerships that can both succeed as a business and address societal and regulatory needs. So if we can bring all these parties together, we can really generate the momentum we need in order to deliver this step change.
Climate change is a very broad topic. The focus of your talk was on energy. Is this the main driver for innovation in net zero solutions?
The focus of the Net Zero Living Lab is very much on clean energy and ways to manage and control energy usage most efficiently. However, the Harwell Campus as a whole has many capabilities that are relevant to broader climate change issues, including capabilities such as space to monitor and manage our changing environment. An advantage of Harwell, together with its sister campus at Daresbury, is that we can bring this full range of multidisciplinary capabilities, including artificial intelligence, digital, space, energy generation, storage and usage, 5G, and many other technologies to address this type of global challenges. So I hope this gives an idea of the breadth of activities involved in delivering this huge initiative.
Thank you, Barbara. If we could now move to Martin now, I have a few questions. Why do we need this transformation in engineering now? Don't we already have capability? Could we wait?
Thanks, Emma. Well, as we saw earlier, many industrial sectors, we've given examples of aerospace, but others such as power generation, automotive, are going from a phase of evolutionary product development to revolutionary and transformational development. And as we've seen, fitting that within a system of systems is a very, very different process. We have engineering processes that enable us to do incremental developments to today's product, but they don't deliver the level of functionality that we need to deliver transformational change and to deliver that system of systems and environment. If we're going to achieve net zero anytime soon, we need to start developing those products now, which means we need the engineering capability now if we're going to have those products in time.
Thank you, Martin. So with question 2, how will we address the broader issue of energy usage in the design of products moving forward?
Good question. This is going back to that effectively whole life cycle modeling. At the moment, the process of product development is actually quite insular, and we don't look at the entire ecosystem. So what we need to consider, and it comes down to both understanding the problem we're trying to solve and actual requirements management, as well as the ability to model the performance of those products and consider the whole ecosystem, which is very different to how we do it today. We tend to look at products in isolation, not as part of an overall energy ecosystem.
Excellent, thank you. And if we move to James, we have a few questions that have come in from the audience around ammonia. So could you give us sort of direction on what other plans could be in the pipeline for ammonia use?
Yeah, beyond aviation, there's several places where you could see ammonia used, particularly as a fuel. In the maritime sector, for example, it's probably one of the leading candidates for using as a fuel for ships, particularly in the deep sea shipping context. It could also be used in any number of places in a similar role to where people are pitching the use of hydrogen currently as well. So anywhere where you're talking about long-term energy storage in a chemical medium, ammonia is a possibility. Anywhere where you're talking about industrial heat or power generation. Virtually anywhere you are seeing a shift towards some kind of zero or net zero fuel, there's potentially a niche where ammonia can play a role.
What are the downsides of ammonia for jet propulsion? So what problems need to be resolved before widespread adoption?
For jet propulsion specifically, it's really a R&D and D problem. So research, development, and then design. It's a very linked problem between the airframe and the propulsion system. So you have to do modifications to both that have to be complementary. It really feeds into stuff Martin was saying earlier about sort of a system of systems approach where it can't just be one thing in isolation. But it's primarily a technology development problem at this point.
Thank you. And could you say a few words just how being part of the Harwell EnergyTec Cluster and feeding into this idea for a net zero living laboratory can help your project or has helped your project to date?
Yeah, I mean, it's been a great partnership to date. I mean, I reached out originally to Harwell EnergyTec Cluster because I was looking for a catalyst, and what I could find pointed in that direction. And it's been a really great experience working with people who have a completely different skill set to my own and can really complement what we're trying to do. Moving forward into something like a net zero laboratory could be very helpful in terms of providing further access to expertise or facilities or other things that would be useful in developing the kinds of products you need to be able to ultimately integrate a viable propulsion system.
Fantastic, thank you. And if we could move across to our final speaker, Eric, we have some questions around the living laboratories. So Eric, when we're talking about a net zero living laboratory at Harwell, we're including, the scientists that we've got there, the equipment, the technical expertise, the links into our facilities. How do you see the Energy Systems Catapult Living Laboratory feeding into this, and how can the two living laboratories work well together?
Yes, thank you for the question, Emma. I think certainly the starting point for working together is the shared ambition that we have for what we want to achieve in terms of net zero. And I know we've started conversations which has established the fact that we have the same ambition, and we also believe very strongly in the role of test and demonstration and living laboratories in achieving that. So I think what we really do need to do, I think, next is understand the use cases and the things that the issues that we want to explore, so that we're doing work that's complementary and not duplicative. I think that's a key thing. And with that, I think we can then understand how our resources will complement each other. Now, the focal point for our work is the real consumer in their real homes, and I think the ability to work with you to gain access to, I guess, broader contexts, broader types of technologies, new types of technologies that might be deployed in our environment, for example, or tested in our environment, would be a key starting point, I think, for understanding how we would work together. I think there are a number of ways. Another way, I think, is the exchange of data, because we collect large amounts of data from the trials that we conduct. We could make that available to you for analysis and gaining insights into ways that might be reflected in new technologies that you're developing in your innovator community. And similarly, there might be a flow of data from the work that you're doing that would be informative and helpful in the types of things that we're doing. So I suppose I would highlight two things in the first instance. One are the core use cases of issues that we want to explore together, and secondly would be the potential to exchange data.
Fantastic, thank you. And just one final question to Barbara. If we can, so Barbara, we've had a question that comes through that's asking why when we're looking at net zero technologies, we're including everyone, all of our organisations in the move towards net zero, including organisations that have traditionally looked at fossil fuels. I was just wondering if you could say, a few words about our multidisciplinary collaboration and our encompassing approach.
Thanks, Emma. Well, it's really important, actually. This is a global challenge and needs to involve everybody. And those organizations have to take direct responsibility into this, and they are willing to work with us to actually help them solve some of the challenges they're facing. So our living laboratory and the ethos on the campus is all about multidisciplinary applications. So all the capabilities of the campus itself and the organizations that work within the campus, the facilities, and also organizations outside the campus need to actually pull together in order to achieve the solutions that are needed for this challenge.
Fantastic, thank you. So I would like to thank everyone that has spoken this morning. If there are any unanswered questions now, we will address them in the follow-up from the conference. So we're now going to move into a coffee break. I mentioned earlier about the resource section and the ability to network on the different tables. If you see people that you would like to catch up with, we'll reconvene at 11:45 a.m. for our panel discussion. Many thanks. Welcome back. For the next part of our agenda, we move into the panel discussion. Please do submit questions through the QBI platform. I would like to introduce Professor Joe Howe from Chester University, who will be chairing our panel session today.
Welcome, colleagues, to the panel discussion. Joining me today on the panel are a number of eminent individuals from industry, from academia, etc. First of all, we have Ian Ellington. Ian, he's head of the Faraday Institution for technology transfer at that particular organisation. Alice Porter. Alice is going to make a fabulous contribution in terms of the UKRI commercialisation activities, because she's Deputy Director there for commercialisation. Thirdly, Paul Beasley. Paul's head of R&D at a blue chip company at Siemens. Professor Bill David. Bill David is the STFC fellow at the ISIS facility and also works at the Appleton Laboratory. Jack Nicholas. Jack's the CEO of QDOT, a University of Oxford spin-out company. Elodie Viau is the Director of Technology and Integrated Applications at the European Centre for Space Applications. So I've pulled together a number of different questions for the panelists. And the first one I want to ask is to Ian. Now, Ian, you're head of technology transfer at the Faraday Institution. And for me, at least, the question that I want to ask is, how does the Net Zero Living Laboratory relate to the Faraday Institute? And what do you see as being the key drivers for a Net Zero Living Laboratory facility?
Thanks, Joe. So yes, I'm head of technology transfer at the Faraday Institution. We're trying to drive UK research in batteries and energy storage to develop the next generation of energy storage technologies. As part of technology transfer, my aim is to identify the best research that's available and commercialise that in the best way that we possibly can. We need to set up an environment where innovators and entrepreneurs can prosper and deliver economic and societal impact as far as possible. In doing that, we're really coming up with commercialisation plans for all our bits of research. We're helping to identify entrepreneurial researchers who want to set up spin-out companies and want to really take their technology that they've come up with to the next stage. And we have a number of schemes for doing that. It's great for us to be at the Harwell site and have access to the zero carbon living laboratory initiative and facilities. Of course, it means is that the innovators that we're working with have somewhere to test out their technologies in a more benign environment as they go through towards commercialisation. What that means is that our entrepreneurial fellows or our researchers, as they're developing those technologies, can find a safe place to work with to really establish the markets and prove them. And in doing that, we're working with the EU on a programme called the STEPS programme, which is an opportunity for innovators in energy storage across northwestern Europe to test out their technologies. So right now we've got a competition open looking for small and medium enterprises from across the whole of Northwest Europe to implement their technologies on testbed sites. And it's great that we're partnering with Harwell to use the Harwell facilities as a testbed so that innovators can bring their technologies to us to demonstrate them in a real environment.
Alice, the second question I wanted to bring to you. I've really been following very closely the development of the UKRI's environmental sustainability agenda over the last couple of years. And I'm left wondering the extent to which the Net Zero Living Laboratory is in a position to support commercialisation. Indeed, how should it be supporting research and development through to commercialisation?
Thank you. Yeah, I mean, I think the Living Laboratory really does offer a fantastic opportunity to support the creation of impact from research. So by enabling support those research outcomes, we can help development through those technology readiness levels, through the commercial development of propositions to really help accelerate taking those applications to the marketplace. And I think by supporting that process of commercialization, you know, ultimately we generate those innovations that are going to create those wider societal impacts in the future. So I think with regards to UKRI's environmental strategy, I think the Living Lab really just offers that opportunity for a truly integrated approach. So that's not only about our own organisation and how we undertake our activities, the collaboration across the research councils and the opportunities for cross-disciplinary working, but also how we catalyse and support the research and innovation that is going to generate those technologies that are going to help us achieve those net zero targets in the future.
Thanks, Alice. I'm just going to come back to you though on one or two issues there. You know, you're Deputy Director of Commercialisation for UKRI. Alice, how do we begin to identify those technologies that will have a far-reaching impact to make a difference upon people's lives?
Absolutely, and I think it's really crucial that we continually horizon scan and really just open ourselves up to the opportunities and the possibilities of how we identify what those emerging technologies, you know, that are going to present real potential for economic impact and wider societal impact and benefits in the future. So I think it's really crucial that we kind of create the circumstances in which those potential applications stemming from the research can effectively flourish and develop. So, you know, the idea of creating a situation in which those ideas can be explored and can be tested and evaluated in a real world environment, such as a living lab, really enables that process of commercialization. I think it not only de-risks those opportunities for investors through demonstration of application, but ultimately it's just going to accelerate, you know, getting those products into society and really making a difference to people's lives.
That's absolutely fabulous, Alice. I'm going to come on to my third question. And the third question, I'm going to direct it at you, Elodie. Elodie, you've got this really superb international background and context. And I guess the question that I want to ask you is, how can we measure the impact of the living laboratory on that international scale, on that international level? And how do we bring through these? And how do we bring through these technologies? What are the breakthrough technologies do you perceive for the future on that international level?
Thank you so much for this question. So yes, at the Harwell Campus, we are in a multidisciplinary and multicultural environment with more than 6,000 employees over more than 150 companies. It's a living lab indeed to develop there, to be a showroom of what can be done, and then to bridge it through the European Space Agency. We are bridging to Europe and then soon to international. So at Harwell, there is already mature companies, SME and startup, with a very diverse backgrounds of culture and domain of expertise. That's where people get together, and we believe that competition is a driver and collaboration is an enabler at the European Space Agency. And it's exactly what is happening locally at Harwell for this living lab, having it as a showroom showing how you can go to a zero carbon environment using the right energy and deploying the right technology, then being this showroom locally, then to be connected through technology like 5G to other places internationally, and being able to then be replicating this showroom developed locally to other campus, and then connecting with various clusters. So the beauty also of Harwell Living Lab is that it's next door to other clusters like the space cluster, the health cluster, and then it's crossing barrier towards the various domain and various environments. So I think that's how it is growing. So an example of what we are deploying at at Harwell is this autonomous driving cars that will use autonomous vehicles that will be fully electrical. So that's one example of how we can deploy, test, validate with SME, startup and mature companies on a local basis. And that will be a showroom release that will have an international and global reach. So that's typically what is cool about it.
Thanks very much for that, Elodie. That's a fabulous sort of summary in terms of how we can potentially begin to internationalize some of these technologies and how we can begin to measure some of these particular technologies. So the fourth question I was thinking about as we've been going through today, really I want to target this at both Paul and Jack. We've got a head of R&D at a blue chip company at Siemens, and we've got a CEO of an SME company. And maybe I'll kick off with Paul. And Paul, what technical and regulatory and commercially challenges do you feel exist at the moment? And how do we overcome them in terms of expediting net zero technology development through to commercial deployment? And I'll ask the same question of Jack.
Yeah, thank you, Joe. I think the issues here really are around kind of bringing in kind of new technologies and evaluating kind of those technologies in a real environment. So currently regulation obviously kind of restricts some of those activities. I think certainly from the technology perspective, we're working very closely with a number of our customers. You can test the technology, but the regulations actually stop us or hinder us really trying to evaluate the business case. Actually having an environment where you can test the engagement of our customers with the technology is also an important kind of factor in this. But really, companies will accelerate and develop that technology if they can see a positive business case. But in order to do that, you need to break some of those regulations in order to try some of these new activities. So that's really it from our side. And I think that certainly the Living Lab offers a great opportunity here, maybe to do this a little offline. But kind of certainly it's something that we started to take on board and work with other kind of campuses in order to trial these technologies.
Thanks, Paul. I'm going to come back to you on this because we may well have colleagues in the audience that want to ask questions from government bodies and from the civil service. To what extent, perhaps, could the regulatory environment actually be an enabling sort of regime in terms of bringing through to commercial deployment rather than a constraining regime, which is what I sense came across in your answer?
Yeah, well, I think the issue at this moment in time is, of course, we're developing new opportunities, and I think in order to proactively change those regulations, you need to have an idea of what's coming along. So it's all about kind of talking, engaging with them, and maybe explaining opportunities in order to actually do that. I think certainly the current environment is a restriction. I think certainly through collaboration and engaging kind of all of these bodies and kind of bringing them together, we can work to establish a framework that can open up and accelerate some of the technologies.
Thanks, Paul. Over to you, Jack, CEO of QDOT, a rapidly emerging SME in this particular space. What do you see as being the technological, regulatory and commercial challenges that you're facing within an SME?
So thanks, Joe. So I think from a commercial perspective, I mean, for a small company, kind of the biggest problems we generally face are trying to get some engagement with potential partners or end kind of user customers. So being on the Harwell site in particular, so we were successful in a bid to something called the Harwell Proof of Concept Grant. That has allowed us to kind of develop a key strategic relationship with a battery cell manufacturer. So the technology we're developing is to enable rapid charging of electric vehicles. Key to that really is the cells themselves. So having that strong relationship and being able to build that through the Harwell Proof of Concept has been very useful to us. Going back to your question on regulatory aspects, I guess for us, for a small company, changes in regulations are potentially an opportunity. We're smaller, more nimble. We can probably adapt to changes in regulatory things much faster than larger companies. So for us, the kind of big change and looks like there's going to be quite a big investment in net zero from the government. That's quite exciting for us, and we feel as though we've joined the bandwagon at the right time in terms of what the technology we're developing. So we're quite excited about that in terms of regulatory changes. In terms of also being on the Harwell site, so I thought I'd touch upon this as well. So it's quite important for small companies. We obviously don't have a lot of capital. We're very resource constrained. So being on the Harwell site, we've also got access to a lot of advanced scientific equipment that you can use on a kind of ad hoc basis. Is very, very beneficial for developing technologies, and one that we've taken advantage of to accelerate the development of our technology.
Thanks for that, Jack. Colleagues, lots of interesting issues coming up here. I hope you're popping those questions into the chat, because I'm just about to come on to my final question, and this is to Bill David. Bill, you're a world-leading scientist. You're a fellow of the Royal Society. You've got the ultimate academic and social capital here. From your experience over the last few years, what would be your advice in terms of ensuring that the Living Lab continues to develop and become a world leader in terms of design and development of net zero technologies?
Right, well, I'm in the very fortunate position, as you say, of being involved in academia, also based at the Rutherford Appleton Laboratory at Harwell, and working quite closely with a number of industries. And I think that the campuses that we have at Harwell, at Daresbury and at Edinburgh are amongst the biggest of the UKRI campuses, and they're not just a national asset, they're a resource, and I think hopefully they can be a national treasure, because what we can do is go all the way from the very basic science, the sort of thing that Jack touched on, and he needs to get an answer with kit that he doesn't have, through to the living laboratory, where we're integrating all the different aspects, for example, of the 10-point plan. It's not just taking one of the ideas, but being able to look at all of them together. And the fact that we've got these fantastic world-leading facilities like ISIS and Diamond, and this potential living laboratory where we're looking at the latest pre-commercialization ideas, that's all based on the one campus. It's, I think, a huge advantage. And as Jack was saying, being able to foster the SMEs, but also to involve the big companies like Siemens is a wonderful thing to be able to do, and it's a unique resource. And I think that I'm just excited about the future in terms of what we can do. My bag is energy storage, and I'd love to see the integration of batteries with the zero carbon fuels of ammonia and hydrogen that I'm working on. And I know that there's the opportunity to do that at Harwell, of integrating heat and power at the megawatt level, actually, and demonstrate at that level is a fantastic opportunity. And all our colleagues around this virtual table together, actually, I think together we express the breadth of who's interested and the opportunities that we have. So I'm just excited about the future.
Thanks, Bill. Colleagues, expediting net zero technologies through the technology readiness levels, from our R&D through to commercial deployment, delivering the net zero innovation agenda, driving and aligning to the green industrial revolution, supporting the levelling up agenda. That's all come across very powerfully this afternoon in our discussion. So now it's over to you to ask questions. So looking forward to these questions, colleagues, coming in. The first one I've got here is from Chris Dunkley, and the question is, within the excellent living lab concept, what provision will there be in terms of supporting scale up for manufacturing? What support will there be in terms of scale up for manufacturing? So, Paul, I'm going to bring you in on that one in terms of scale up for manufacturing from Siemens. Paul?
Well, I can't really comment on what's going to be on the Harwell campus, but certainly kind of for Siemens, we're obviously want to utilise the living lab in order to demonstrate the integration of technologies. So I think really. That's certainly an opportunity to bring together the system of systems, as many of the other speakers have spoken about. How that's kind of taken kind of back to the kind of the companies involved in that, really, it's down to them.
Thanks, Paul. Next question coming in about scaling up. It's more to do with capacity and the skills side. So, Bill, I'm going to bring you in on the skills side as an academic and someone very much involved with STFC. And the question here is, what do you think we need to develop the UK workforce to deliver the net zero skills ambition?
Well, as an academic, I'm probably the least qualified to be able to say that, coming from an ivory tower. But one of the things I want to pick up is in what Martin Aston said earlier on. Actually, there is, a real need to engineer ourselves through, actually, and science underpins all that we do and can inform how we go forwards. But it really is building up this engineering base of expertise that we can actually make these things happen. And it's finding partnerships between universities, living laboratories, SMEs, and the blue chip companies. And again, I think that, we see all these people, on the Harwell campus, at the facilities. We see a huge number of people moving through, and it's getting that conversation, working with people as well, actually. And it's securing the funds to be able to move forwards, both in terms of public and private partnerships. And so it's getting, the real force of government behind what we're doing to really make this happen.
Okay, I'm going to throw the same question at Jack as an SME CEO. The skills piece, Jack. What do we need to do to develop the skills piece for the people that you're looking to employ as you build your company?
Yeah, I mean, it's a difficult one. It's one we struggle with ourselves, really, is sourcing people, especially in the area that we work, which is in kind of electric powertrains. Is obviously quite a hot area at the moment. There's a lot of demand for people, and there's not enough around. So there's definitely a need to train those people. How we go about doing that, I think from our perspective, if we could have some support that would encourage us to take on things like apprentices, maybe. I know that obviously exists for kind of big OEMs like Siemens, but for us, it's not as simple to do something like that. So we're kind of ready and willing to take on people and try and train them up. But I guess it's that kind of how we do that through government in some way, really.
Thanks, Jack. I think there's lots of opportunities out there in terms of skills. Certainly the government through the Department for Education, looking at the post-16 education reform agenda right now. The issues of skills levy and apprenticeships are high on the agenda as well. So I think there's a real focus in terms of the government, the Department for Education around the opportunities afforded by the green recovery in relation to skills. So I think all of us would be really excited about that, the whole skills piece and building the supply chain to deliver on net zero. The next questions come in from Professor Anonymous, and Professor Anonymous asks, what one piece of regulation would each of the panelists like to see passed? So what regulation would we like to see passed? So Paul, you talked about regulation before, so I'm going to bring you in first of all on this. What one piece of regulation would you like to see changed or passed?
Well, I mean, kind of for us, really, I think the opportunity here is to try to accelerate some of the technologies and the services, kind of bringing together different aspects. So not just the electrical system, but kind of data in order to optimize that. So it's gaining access to all of those elements of data, being able to kind of utilize them, bring them together to optimize the system. And there are kind of various kind of regulations around kind of data access in order to actually do that kind of sharing of data. But then the ability to actually to try to do that, of course, regulation is there in order to protect the end consumer. But unless we actually identify business case and business opportunities, then there's really it doesn't really kind of strengthen the levels of investment in order to try to do that. So yeah, we need to try and find a system whereby we can obviously bring all of these elements together to demonstrate the systems, but doesn't obviously impact in a severe way the end user customer.
Thanks, Paul. Over to you, Ian, on this particular issue in terms of what piece of regulation would you like to see change, amended, passed to enable you at the Faraday Institution accelerate things, etc.?
Well, I'm not the world's biggest fan of regulation or taxes. But for the net zero agenda, clearly some sort of carbon tax will really drive forward some of the innovations that we see. And for batteries and getting a battery industry, then the bringing forward the winding down of combustion engines in vehicles would clearly be advantageous to getting investments into batteries and electric vehicles.
Great, Ian. And I'm going to bring Alice in on this as well from a UKRI perspective. The whole impact agenda, clearly, what piece of legislation do you think needs to be enabled or changed to speed through, accelerate, expedite some of these technologies for some of the fabulous funding that UKRI are putting out into this to commercial deployment?
Yeah, I mean, I think we really have to think about the kind of practical sort of implementation and adoption of technology. And I think one of the things that really kind of comes to mind for me, and kind of linking back to you know, electric vehicles and so forth, is actually the restrictions around our current planning regulations. You know, how are we actually going to integrate this infrastructure into our built environment? So I would certainly like to see things that would really expedite actually how we get electric charging points into our streets that are accessible for all, not just people that perhaps have you know, private driveways and a space to be able to charge their vehicles off the street.
Thanks, Alice. Elodie, a question is coming for you, actually, specifically just for you. Look, and it's a great question. How can the ESA support the re-engineering of engineering to expedite technologies?
Yes, that's a great question, and that's true that we are trying to support these activities within the European Space Agency, because as I was mentioning earlier on, we are trying to build those hubs where we get the engineering and system of engineering together to actually facilitate from the end to end the demonstration and the trial of new application. So we were just talking about autonomous car, and there is it's not only the space, but it's also space plus energy plus engineering systems that gets together. And also we need also the skill of the business to make something sustainable and profitable and for the long term. So that's really all the fields that are getting together. And so we have this way of looking at engineering at various angles and on a step-by-step approach. Like that, you can innovate in a constant manner, but not wait the full innovation to be ready, but really include some agile methodology like the IT has been doing in the past. So taking those technique in other engineering field and applying it here in the energy domain to achieve the zero net target. That's what we try to produce at ESA, and with the like really in collaboration with all the industry and university.
Thanks, Elodie. I've got a question coming here, which will be of real interest to, or the answer to which will be of real interest, particularly I think to the SMEs, but maybe to other businesses as well. And I'm going to throw it both Alice and Paul. It's from Nick Rimmer, and it goes, what are the most effective business support mechanisms? ... Cash grants, tax breaks, access to facilities, mentoring, access to academics, etc. So over to you, Alice, from a UKRI perspective in terms of commercialisation.
I think I kind of have to say probably all of those things in sort of one mix or another. And I think the important thing here is about really making sure that we have a kind of continuum of both funding and support available to really help you know, these ideas and proposition kind of through their commercial commercialization and development. So I think it's about having the right balance, the right suite of support available, and really just recognizing as well that you know, commercialization is not a simple kind of linear one approach kind of pathway. So we need to recognize the different types of interventions and support that these propositions are going to need.
Thanks, Alice. I am going to take this question over to Paul and bring in Jack as well, so that we've got almost opposite ends from the SME right the way through to the blue chip on this particular company. So access to support, Paul.
Yeah, thanks, Joe. I think the other, I think all of the above, as Alice mentioned, you know, are of interest. I think the only thing I'd add in there as well is opportunities for collaboration, kind of bringing people together. That's universities, companies, SMEs. this is now bringing together a very diverse kind of groups of technologies. Within Siemens, obviously we have a quite a diverse portfolio, but again, there are elements where we're kind of collaborating with universities, with many of our customers in order to actually deliver some of these solutions. And I think it will need that, and certainly the Living Lab gives the opportunity in order for those sort of collaborations in order to happen and to spark and generate other new solutions and new ideas.
Thanks, Paul. Jack, extending that question, so what's made you spark, and what's made QDOT spark, and how has it happened for you at Harwell?
Yeah, so just going back to what Paul was saying there, I think I'd double down on what he was saying about the kind of the complexity of systems we're looking at these days. So it's very difficult to solve a whole problem in isolation. And we're finding that ourselves, that you start trying to solve one bit of a problem and realize it has a knock-on impact on another part of the system. And so then you have to start building partnerships to deal with those parts. So I think, yeah, so for us, the big advantage from that point of view, being on the Harwell site, is the access to a lot of other SMEs on the site, some OEMs as well. And then also from a resource perspective, we're obviously very cash strapped as usual as an SME. So things like facilities that we can access that would just be too capitally intensive for us to purchase ourselves is also a very useful thing. And then touching upon the Living Lab idea, I think from our point of view, one of the most difficult steps is, okay, you prove it at a prototype level, you prove your technology at a prototype level. How do you then take that to kind of an end user? And it's that step, and I think particularly in the Living Laboratory, if there's an opportunity to do real life validation of a product before you then maybe have to kind of give it to an end user or take it to an end user, would be hugely valuable from our point of view.
Great, Jack. Thank you. Next question is one that's very close to my heart and something I'm very passionate about, colleagues, and that's skills. It's fabulous doing all of this energy technology development, but we need the skills in place in the UK to make sure that we maximise the economic impact, that we have the supply chains in place to deliver. But for Paul and others on the call in the big businesses and in the primaries, and to align the supply chains into this. So, Bill, I'm going to ask you the question as the academic on the panel. From an academic perspective, are new courses aimed at energy transition being explored at the Institute to meet the skills challenge? So that's to you, Bill, and then I'll also bring in Ian on that.
Two things I'd say there. Actually, one is that really, having theoretical courses that teaches you about the challenges that you got. That's one thing. Actually, having a living laboratory where people can come in and twiddle the knobs and and see how the energy systems balance. That's the important thing to be able to do, is to bring people in to have the opportunity to be able to use these facilities. And then, speaking as somebody who's worked on large facilities all my career, I mean, we do a huge amount of training to bring people up to be, experts in neutron scattering, in X-ray diffraction. We need to do the same thing with these facilities. And so a theoretical course is one thing, but getting people to actually do the job, to be able to work alongside Jack, maybe be the, not an apprentice, but somebody who comes along and and gets an idea of how an SME works, or works with Paul in terms of these big companies. I think it's important to be able to do these things. The other thing in terms of education is bringing the public along with us, actually, and having them involved, and having outreach to the public, and inspiring them about the opportunities that there are there, and bringing people in and seeing that we have the small companies, the big companies, and UK is open for this transition, and there's huge opportunities as well. So I think the public's very important as well to bring along in all this education.
Ian?
Yeah, skills is a fundamentally important part of the change process that the country is going through. Really, it's a revolution in energy and technologies, which at all levels needs different skill bases. So as part of the Faraday Institution programme in the battery research, we've kicked off at kind of the research level, and we're running PhD programs that are broader than a typical PhD program. So we're including elements of a mini MBA in there to help people think about the business context of what they're working on, as well as giving them the insights into to deep battery technology and research. But we're also working on postgraduate courses. We're working with Warwick Manufacturing Group, who already deliver an amazing introduction to batteries. We're also working with the Advanced Propulsion Centre on both postgraduate and school level training and the sorts of skills that are going to be needed really right across the economy, and everything from basically car repairing to the emergency services. We've got people investigating the safety of batteries, training people on battery safety. We've already got academics from Newcastle University who are having to train the first responders and the emergency services. So yeah, it's a big program, and as we're identifying the gaps in skills, we're trying to put in place programs to fill it as part of the Faraday Institution core activity.
Thanks, Ian. Question for you again, Paul, coming from Hugh Sullivan, and the question goes, what do you need as a blue chip company to make your business case to invest in a capital facility to build long-term GDP growth to manufacture some of these technologies?
Well, in simple terms, obviously, the size of the market, return on investment, the usual sort of things there. I think certainly, as we mentioned, this is kind of mashing together lots of new technologies, new services. It's not the case of solutions in the past where you just bring up a box, replace one box with another box. Here, there are opportunities to deliver, new solutions, new services. So certainly being able to de-risk kind of those and evaluate whether the technology is something that our customers will accept. It's not that box anymore. This is something that's new. It's no one's seen it before in many cases. So again, it's trying to reduce those levels of risk, but at the end of the day, it's down to return on investment and the size of the market.
Thanks, Paul. I'm sure that'll be helpful to many people that are in the audience today. I'm sure there'll be a lot of interest in that. Question here, I think it's going to go to Bill. It's about the Harwell Cluster. You'll love this question, colleagues. The Harwell Cluster is clearly world-class in terms of physics and engineering, but how does the living lab plan involve experts from other disciplines to build the transdisciplinary teams that will ensure its innovations really deliver the positive impacts needed to mitigate and adapt to the impact of climate change? Bill.
Right. So yes, there's a lot of physics and engineering, certainly, at the Rutherford Appleton Laboratory. But if you look at the Harwell Campus, it's not just EnergyTec. We've got space. We've got the health cluster. We've got Public Health England there on site already, so that Ricardo on site actually are handling the environmental side of things. So there's much more breadth on the Harwell campus than just energy and just physics and engineering. But yes, there's probably a balance towards the physics and engineering, and absolutely we need to be looking at the biological and the social science side of things as well. That's something that needs to grow, definitely.
And I'm going to bring Elodie in on this question as well in relation to the impact upon your work, and how do you think this transdisciplinary research that goes on at Harwell and transdisciplinary working has supported you in your business to potentially position yourselves in relation to the challenges of climate change, etc.?
Yes, so that's thanks for coming back to me. That's very close to my heart as well. This transdisciplinary and all the cluster working together in Harwell. So that's the beauty to be like on the campus, close to each other. You can go bang on next door and discover something's going on, and then it's clicking ideas, because the solutions are coming from people getting together and fostering those new ideas. Because we are opening a road where you have plenty of new things to invent and create. And we are just at the edge of this transition. And now people have the conscious of the importance of going towards a net zero target, and to really and getting together to bring those applications, those new services. So having, for example, being on the telecommunication and the space domain, you wonder like, why I'm here? Well, it's because space is like energy, right? We need to have the infrastructure, we need to have the to connect things, and in fact, we are very close, and we will empower them to be able to monitor how they spend this energy, how they do, and so that's where we are actually very close field next to each other that can bring new solution if we work together. And that's why it's very important for me and for the European Space Agency to be here today with you, because we want to show that we will bring a solution together with the energy domain. So we should not think about silo of, we should think about clusters that are getting together to find solution.
Great, Elodie. Next question that's coming is from Matt Thomas, and it's a fabulous question. It's about supply chains. So I'm going to bring in Paul again, and I'm going to bring in Jack again, at perhaps slightly different ends of the supply chain in many respects. Can you give any advice on how manufacturing supply chains contributing to the UK net zero energy capabilities ensure that their own operations have a low carbon footprint, or as low a carbon footprint as possible? What do you think is the current best sort of in class at this? Paul?
Well, I think we stole a little bit of a march. I think 2014, we as a company kind of globally decided to drive towards net zero, and we have a target of doing that by 2030. I think we're kind of well ahead of our strategic plans, and there are some discussions about potentially bringing that forward to 2020. So certainly that involves many of our kind of bringing many of our supply chain and our customers and you know, to the same sort of level in order to achieve that. So certainly obviously deploying those technologies to ourselves and demonstrating that these things can be achieved hopefully will encourage and develop those supply chains, other customers, in order to deliver that. And so we're working with a number of other campuses, you know, to bring along the skills and everything that's required as well, not just for Siemens, but you know, we have to look at the wider supply chain as well, and kind of pushing those skills kind of back down to suppliers, SMEs, in order to achieve this. So yeah, it's a good target, I think. So we're well on the way to actually achieving that, and certainly bringing many of our supply chain and customers to the party as well.
Fabulous, Paul. Jack, Paul's pushing it out to the SMEs to do this. How are you doing it in terms of your low carbon footprint? Jack? You're on mute, Jack.
Someone was going to do that at some point, so I'll on for the team now. Yeah, so it's a difficult one for an SME, because there's a bit of a tension there between kind of getting a product out in a timely manner, and I guess making sure everything you source in building your product is hopefully net zero or is low carbon impact. In terms of impacts of what we're doing, I guess the biggest impact is on probably design considerations and choices of things like materials and manufacturing processes that we use to make our products. It's a bit of a different ballgame, I guess, from what Paul's doing in terms of the scale. So we haven't got a big infrastructure of a supply chain that we're working with. We're trying to establish a supply chain as we develop our products. So we're just trying to be conscious as we do that, and making sure, yes, that we're making the good decisions early on, so that we can be net zero when we get the final products completed.
Many thanks, Jack. Next question, I'm going to bring in, I think, looking at the panel, Alice and Bill to this one. And I've got an amazing postdoc from the School of Chemistry at the University of Edinburgh that's developed this novel solar cooker using high temperature phase change materials. And they want to know how they can find an opportunity at our Harwell's Living Laboratory. Is it through the UKRI, for instance, or are there other schemes as well? Alice?
Yeah, I mean, certainly there would be opportunities to explore that through UKRI, and certainly our Future Leaders Fellowship funding would be a really great opportunity to explore that. And that kind of really brings together the kind of innovative exploration around the kind of academic opportunity, and linking that in with a business that might be able to help you explore and progress your ideas. So would absolutely welcome an application to FLF to be able to explore that one.
I guess I could probably jump in there as well. So from our perspective, so we got some initial investment from something called the UK Innovation and Science Seed Fund, and that funding is actually tied to campuses like Harwell. So that would also potentially be another avenue that they could explore in terms of trying to get their idea off the ground.
Yeah, if I can pop in as well, I see that I'm aware of this phase change technology and of SunAmp, which is actually a spin out that's involving the University of Edinburgh. And the whole, we talk a lot about energy, but the heat is really important as well. What I think Harwell can offer is up at the megawatt scale, actually, to take these things beyond perhaps what you might have as a laboratory demonstration in the university and take it up to that next level. And so there's opportunities, and I think this work has been substantially funded by Innovate as well, actually, and it's doing that in a connected way across UKRI. And seeing, what can Innovate and EPSRC and STFC on the Harwell campus do together. And so taking this to the next level, I think that we should be in a place to be able to help this sort of great idea moving forwards.
That's great. Panelists, I think we're reaching the end of our time. Sorry, Ian, I know you want to come in. I know the rest of the panelists want to come as well. But
this is a direct answer to the question. There's a program called Modern Energy Cooking, Loughborough University. Talk to Ed Brown. On behalf of DIPID, he's looking at cooking solutions for solar. So just contact Ed at Loughborough.
Thanks, Ian. So it's Ed Brown we have to talk to about cooking in the energy transition, and we want Ed Brown to engage with the Living Lab. At that point, colleagues, thank you ever so much to the panelists and to all the people in the audience that have provided the questions. I believe at this point I'm handing over to Emma. Is that right, Emma?
Thank you to the panel. Hello, hi there. Thank you to the panel for leaving us with a greater understanding on how we can expedite net zero technologies in the UK and such a thought-provoking discussion. I'd like to thank the expert panel for their time today and say a special thank you to Professor Howe for chairing the panel session. I would also like to thank our key speakers and the joint venture marketing and communications teams at the Science Technology Facilities Council, UK Research and Innovation, and Harwell Campus Management who've worked so hard to stage this virtual conference for us today on behalf of the EnergyTec Cluster at Harwell. I would like to mention Fieldhouse Associates for their media support, the CubeI team for providing such a fantastic conference platform, plus live streaming on the day with positive momentum. And Steve Makin, our professional videographer, who has done a really wonderful job recording our speakers and panel for the event. The government's Green Industrial Revolution and recently published 10-point plan provides an exciting opportunity for cutting-edge net zero technologies, collaboration and partnerships. We would like to take this opportunity to invite everyone here today to join us in moving the net zero agenda forward. I will be following up with everyone individually, and please do get in touch if you can work with us to develop some of the world-leading solutions. Thank you, and I hope that you enjoy the rest of your day.